So hi everyone, my name is Paul Koufalis. I'm here to talk to you about the poor, neglected remote client. So interestingly enough, a few years ago, I did this talk called Benchmarking Network Data Transfers, and it was really popular. I did it at a bunch of pugs around the world, and we really talked about this concept of client server and how you can optimize client server connectivity. And really, with virtualization taking over, and now you've got this hyper convergence happening, we've taken that client server level kind of to a whole other level, and application architects are requiring also now to separate the application layer from the database layer. So again, you're seeing more and more complexity, more and more issues around these network communications. So I said, you know what, it's time to do another talk, some more benchmarks about this. All right, so we're seeing more issues related with infrastructure related network performance issues. And so let me show you a bit of what we saw. So what are we going to do? I'm going to cover some basic info. Most of you probably know this stuff already. That's fine. I'm going to try to go through it relatively quickly. Then I'll talk to you a bit about the benchmark tests that I did, a few real world examples from our customers. You know, we have customers all over the world who are running client server applications, app server, PASOE applications. And then we'll close up with some final thoughts, and I'll be able to take your questions then. All right, so who am I? I've been doing this since 1994. I don't even know, that's 27 years. I'm not a programmer. Please don't ask me to write code. That's Tom's neck of the woods, Mike Fechner's neck of the woods. I don't write code. I'm a technical guy. But the fun thing is that, you know, at Whitestar, our smallest client is like 10 users. Our largest client is 5,000 users, more now, 10,000 users. I lost track. So we kind of get to see everything. So it's a lot of fun for us. We get to see different things, different hardware, different infrastructure, different applications. So we have a pretty good view on things, which is pretty cool. And I got twin 8-year-old boys, which keep me on my toes, let's just say. All right, so let's start with the basics first. All right, so there's 3 ways to connect to an OpenEdge database. Kind of the classic way that everybody knows is the shared memory connection, and that's where the client really connects directly to the physical database files, connects directly to the memory segments that the database is using, and essentially does everything by himself. We call it a self-service client, right? Because he goes to the buffet and he takes what he wants, and there's maybe a few people around there to help him out if he needs a bit of help, but essentially you're on your own. Then you can do client server, and that's really the focus of this talk, 4GL client server, and finally SQL, which is also a client server type of connection. And what does that mean? Like I said, with shared memory self-service, you kind of do everything yourself, and with client server, you've got this other process that does work on your behalf. So you ask some process on the server, hey, can you get me this information, please? He does the work for you and sends you back the information. Pretty basic. So what's the problem with client server communication? So the first problem is really that a lot of code out there is legacy 4GL code, and it wasn't really written with the client server costs in mind, right? It was written with the thought that the record is right there in memory. You can grab the whole record, pick out the fields that you want, and you're done, and everyone's happy. And as client server takes over more, as we separate the business logic from the application logic, we're realizing that reaching across the network, you know, to grab the entire record or to grab 4,000 records, but we only need one field in one record, that's maybe not the best way to do things, and we're paying that price. And you know, that communication can be very chatty, you know, back and forth, blah, 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 right? Like me, like my kids, chatting. So how do we fix this? There's 2 ways to fix this. One, we need to talk less, and that's a problem for me, but nonetheless. And the other thing is we need to say more. So within the context of the less words, let's put more meaning into the words. And let's condense what we're saying and do as much as we can in as little words as possible. So How do we talk less? This is really all your code. So, we talk to programmers. I think a lot of you are programmers listening here. You need to optimize your queries. You need to use no lock unless you specifically are looking to modify a record or you really want to get a shared lock on a record, right? So if you have legacy code that defaults to shared lock, fix that code, right? Use field lists if you can in your queries. So you don't need to bring a 600-byte record across the wire if you only need the name of the customer or the phone number of the customer. So use your field list. And certainly avoid this find one, because now you're just shuttling one record at a time across the network. It's very, very expensive to do that, all right? So these are kind of things, and you can find the benchmarking network data transfers talk. It should be on the pugchallenge.eu website. If not, just email me and I'll send it to you. So I talk a little bit more. And just to give you a taste here, you can see here in the taste, like if I just do a normal for each customer, I can push about 39,000 records per second in this benchmark. And then all I did was change it for each customer, no lock. So same thing, a client server communication, and just by adding no lock, I was able to almost double throughput to almost 70,000 records per second. And then guess what? If I go here and I say, you know what, I really only need the customer number and the name. I don't need to bring the entire customer field. Now I'm up to 104,000 records per second. So you can see simple changes to your code, and we can triple throughput by cramming as much information as possible into as few conversational messages, if you will, as possible. All right. And so again, this is in the benchmarking network data transfers talk. So I'm going to jump over this, and I want to go more into the technical DBA side of things, right? So let's talk about using bigger message sizes, and let's talk about forcing more information into each one of these messages. So what do we do? On the OpenEdge side, there's this -mm message buffer size parameter, and the default value is 1024. It's very, very small, right? And so network MTU is typically 1500 bytes minus the header. It's a little bit less. So you're essentially shuttling data back and forth on the network, typically in 1500 bytes. There's this concept of jumbo frames that I talk about also in the other talk that you can look at. But really, you're shuttling data. So we kind of would have expected matching the physical network message size with the OpenEdge network message size would be optimal, but it turns out that that's not true, and I'll show you later. We want to have a larger OpenEdge message size, and you'll see in a minute, right? Now, if you were before 11.6, you really had to set the -mm parameter on the server and the same -mm parameter on the client. Otherwise, you would get an error message that they didn't match. And as of 11.6 or so, the client will just take the value from the server. So even if you set the value -mm on the client side, it'll be ignored. It'll take whatever -mm was set as the startup parameter for the server process. Now, the second set of parameters I want to talk about are these prefetch parameters. They were added 10.2b03. I think they weren't exactly 100% till around 10.2b06, and then somewhere in the middle 11. So if you don't have these parameters, you should turn on these parameters. You should use them. And really, I want to focus on these ones here, prefetch numrecs, and that's how many records can you stuff into one message. And then prefetch factor is how full do you want to fill that message percentage-wise. And these two play off each other. So you want to set both numbers relatively high. And I'll show you here. And really, I'm jumping ahead as usual, but you want to set prefetch numrecs to some number like 9999, larger than you'll probably ever have as a number of records in a message. And then you always want to set prefetch factor to 100%. So just default those prefetch numrecs 9999, prefetch factor 100%, and these are database startup parameters. All right, so let's see some data. What did I do? Here in my home lab, I created 2 virtual Windows 10 environments. Now, the physical VMware ESXi server is sitting right here in my office. So I put 2 virtual machines on that VMware ESXi. I took my desktop computer and I took my laptop. So all of them are on 192.168.51.x. So we're not routing, we're not jumping over things, we're not going outside of this LAN. They're all physically connected into the same switch. So I've eliminated as much of that complexity as possible for this simplified benchmark. Why am I telling you so much about this? Because in your work environment, you're going to jump a lot of hoops, right? Your clients who are running your OpenEdge application or who are running a web browser, they will not be on the same VLAN likely as the server. And it could very well be that your PAS-OE or your classic app servers are on a different VLAN from your physical or your virtual database server. You might have some parts of it in, for example, in a DMZ. So there's lots of network hops going on, depending how your network is set up, depending how the architects have placed things in different VLANs. So I simplified this as much as possible, but keep that in mind when you're looking at your own environment. I also didn't play with MTU, so it's 1500 across the board. So you can look at MTU on your server side only, right? So if your app server and your database server are both kind of in the same VLAN on the network, you can consider looking at enabling jumbo frames and seeing if that improves your throughput, for example. So how do we do our benchmarks? ProTop, of course, Sports 2000 database. Important for us to give you the tools that you can repeat these tests in your own environment. There's nothing here that you can't do yourself. We're using the user experience, shared memory, local host, client server metrics in ProTop, and I show you the link. You can go look, you can go try this, you know, in half an hour on your own environment. All right, so very, very easy to do. So what's the ProTop user experience metric? So we said, let's, again, simplify a benchmark here. It's not that it's not meant to be real world, but we're trying to create a benchmark that anybody can use on any OpenEdge database. And so what we do is we read the metaschema tables, underscore file, underscore field, underscore index, so on and so forth, that we know exist in every database. We also are pretty confident that there's going to be no disk IO, right? So those metaschema tables are going to be loaded into shared memory, and we'll be reading from shared memory. So we eliminate any disk IO issues from our benchmarking. So really, really interesting as a benchmark. And finally, what's cool about this user experience metric is I can run the exact same benchmark in shared memory. I can run it in client server using -h localhost, so using the loopback driver, and I can do it in client server across the actual network. And I can compare the three graphically, and you'll see I'll show you the results here as we go through. All right, great. So how did I do my tests? Well, I told you I've got 2 physical computers, 2 virtual computers running in VMware ESXi. So I enabled the client server test, physical to physical, virtual to physical, physical to virtual, and virtual to virtual. So I said, hey, let's go test these 4 different things and see what kind of interesting numbers come out of them. All right, let's see. So number 1, I said, hey, usually we start with the horrible stuff and then we show you better and better. No, I'm going to show you the good stuff first, and then we'll get worse and worse. All right, so we'll start with prefetch factor 100%. So we're saying, you know what, try to fill those message buffers as much as you can, and each message is 8192 bytes, right? The OpenEdge message size. Set prefetch numrecs to 64. So again, the maximum records we're saying we'll put in a message 64 records, and the maximum fill factor 100%. You're going to hit the first one. Whichever one you hit first is the one that's going to take over. So which is why I said in the earlier slides, set prefetch numrecs to 9999, for example. And prefetch priority I talked about a little earlier. So let's see what the numbers look like here. So first things first, BOGO MIPS. So BOGO MIPS is a measure of single-threaded CPU performance. And we use this so that we can compare one machine to another. And so what that's telling me here is, it's telling me here that vSports and VSP2, my two ESXi boxes, are the same CPU speed, which makes sense because they're running on the same physical CPU. But my sports database, which is running on a desktop, is a little bit slower, and my laptop is a little bit faster. L for laptop sports. All right, so that's a little bit faster of a CPU, and that shows up here in this user experience shared memory. Now our expectation is that shared memory really correlates quite well with the BOGO MIPS that we have here, and you'll see that that's true as we go through the various tests. And so the two virtual machines can do both around 425,000 reads per second in shared memory. My desktop can do 300, and my laptop can do 500,000. Now here's where it gets interesting. For a reason that I really can't explain to you right now, one virtual machine could do 200,000 reads per second in minus capital H localhost, and the other one could do 250, right? And the number is pretty clean across the graph. You can see it. There's not that much variation. Why? I'm not really sure. I mean, there's some minor differences in the virtual machines. They're both running 12.3, so I think all of this is on 12.3. So honestly, I don't know why or how the difference is. And why am I pointing this out to you? Because these numbers are not as clean cut in every environment. We just see a lot of variation from every, one customer environment to another. So it's really important that you test these numbers in your own environment to see if you are going to be surprised. So interestingly, like I said earlier, the shared memory to BOGO MIPS it's pretty consistent, around 55 or 60, right? But the shared memory to localhost ratio, that one varies, right? From anywhere from 1.7 to 2.5 in terms of the speed. So now we're going to go to the interesting stuff, which is client server. So remember, we're doing physical to physical, physical to virtual, virtual to physical, and so on and so forth. And so here we see much bigger variation in user experience client server, right? So we can see here that my ratios they go all the way from a 1.7 to 1. So on this vSports, this ESXi box, who's being hit from the other virtual box, so you can see it says here, we're doing V to V here, virtual to virtual, and I'm only getting 120,000 reads per second across the NIC, right? Versus 200,000 reads per second that I was getting when I was doing a local host. Now, for this guy here, VSP2, I've got one of the physical laptops talking to that database and client server, and here I dropped from 250,000 to 80,000 reads per second. And then here, interestingly, again, going from a virtual machine to a physical machine, I lost about 50% down to 75. And here, wow, now this really surprised me. Going from my physical PC to my physical laptop, we dropped by a factor of 4 from 200,000 reads per second to 50,000 reads per second. Now, why? Who knows? My laptop is an HP. It's a piece of junk. I don't like it. Even if it's fast, it's an HP. So it's probably the fault of my HP laptop. I'm never going to buy an HP laptop again. Sorry if any of you work for HP, but we're going to go back to Dell as soon as this laptop does its, does its time. But interesting to see these kinds of numbers and the differences here. And in ProTop, the free version and the commercial version, you can graph all of this data. And really, in terms of the graphs that I'm showing you here, the only difference between the commercial version and the free version is how much time you have available to you, right? So in the commercial version, you can have up to, as infinite amount of time will save all the data for you, and for years and years and years in the commercial version, whereas in the free version we keep, I think, 48 hours of data that are visible to you. Now we have all the historical data, so if you ever convert from a free user to a paid user of ProTop, you'll get all the historical data. But in terms of using the free version of the web portal, what you'll have visible to you is 48 hours of data. But that's more than enough for you to do these benchmark tests on your environment, right? You can run the benchmark, grab a screen capture and say, all right, here we are, here I am, at this time, these are my numbers. Let me change them, restart the server, run the benchmark again for a few days and see what happens. And the other thing that's interesting about trending this data is you might see variations in the data that are not related to a change in database parameters. So what happened here? I didn't change any database parameters here. What happened? And we see this in production where there's some kind of operation that occurs at some point in time that affects the network performance. Or we've been at customers where we've seen this number degrade over time, so nothing has changed in terms of the database. So BOGO MIPS is constant, user experience shared memory is constant, user experience localhost is constant, but our performance across the network interface card is dropping, and invariably it leads to some infrastructure problem unrelated to OpenEdge, but you're sharing your network with so many other components. Again, especially in a virtualized, hyper-converged environment, there's more complexity, more shared, more layers of resources that are adding complexity and adding potential for problems to your environment. So having this historical view so that you can go back to your infrastructure team and say, what happened on Sunday at 2:46 p.m. because my performance went to crap exactly at that point in time. And we all know what the answer is nothing. We didn't do anything. And then the second answer is, well, we made a change to this thing, but it has nothing to do with OpenEdge. And then the third answer is, when we changed this thing, it might have done, and then next thing you know, sure, that's the problem. But having this trend data visible to you really makes it easy to go back to the infrastructure people and say, we know you made a change at this time. Go through your change requests, go through your changes, tell me what changed, even if you don't think it's related. And you'll get a much more serious response if you've got a graph versus if you're just talking to the guy and he's like, get out of here, DBA, I don't care about you, we didn't do anything to your infrastructure. I checked, everything is fine. That's the other classic thing we get. I checked, everything is fine. Performance is great. So really good to grab these. And again, even with the free version, just screen capture these every now and then so you have some history of your network performance. Okay, so let's talk about a couple of things that happened here. So BOGO MIPS, we said, was pretty consistent. That was cool. All right, and we were looking at all of our customers, right? ProTop is running on, I don't know how many thousands of databases literally around the world. So we have data from thousands of databases, hundreds of servers around the world. And there's a project to actually try to correlate all this data, bring it all together and see if we can see some interesting trends in the data across Windows and Linux and version 9 and version 10 and version 11 and version 12, AIX, everything that's going on. So hopefully we'll have time to make a blog post about that over the next few months. I mentioned, that, oops, sorry guys. I mentioned that VSP2 and vSports, identical VMs, same physical frame, but they had significantly different localhost numbers. I don't know why. And the lesson here I want to really highlight is your mileage will vary. So please test in your environment, right? Test if you're making changes, test if you're migrating to a new hyper-converged or a new VMware farm. If you're doing anything, if you're putting in a new switch in your environment, test before, test after, so you have the data. So it happens so often that we get the phone call after, but it's too late. I don't have the data before. So we're kind of guessing how it might have been before, and this is how it is now. So having the data across significant infrastructure changes will really help you quickly diagnose these performance problems. And especially when you're putting new hardware or new infrastructure into place, it can really help you prevent putting production onto a problematic configuration. And again, we see this all the time. So let's do test number 2. So we said, all right, hey, you know what? I want to jam as much stuff as possible here. So I'm going to increase my numrecs from 64 to 9999. That's what I told you earlier was my, my basic, number. Use this all the time. And I'm going to increase my message buffer size from 8K to the maximum supported value of 32,000, right? So what could go wrong? More records, fill the buffers, bigger messages. Let's go faster. But of course, if I'm showing you this, it's because it wasn't faster. So what was surprising here? So BOGO MIPS and user experience shared memory, those numbers didn't change. We didn't really change any parameters in the database, only network parameters. What changed that was surprising was that my user experience localhost numbers changed. So I'm not even going out on the network, I'm staying within that loopback driver, and I still lost significant performance in my localhost. And why did that happen, right? So interestingly, we can theorize. I think the reason why these numbers are showing up like this is because the meta schema tables, there's just not a lot of records in there, and they're not very large records to begin with. So now we said, you know what, fill this very large message and send it across the network, but there simply aren't enough records in the meta schema tables to fill this 32,000 byte message. So I think we're just sending a lot of hot air across the network here. So that would be my theory. And the way to test this would be to repeat these tests with a large table with a lot of records, and then to see if the numbers stay flat or maybe even improve, right? So again, the message is always the same. Test this in your environment, because here are surprising results, that we weren't expecting, and we need to do the postmortem and say, well, why do we have these results? Okay, in this case, I'm theorizing that it's my benchmark that's the issue, but you might find that there's really an infrastructure problem that you need to deal with. And then when I look at client server, you can see the numbers really didn't change all that much in terms of client server. And that's also interesting. So how come when I do the same benchmark with minus MM32,000 in localhost, I lost performance, but across the network, I didn't lose performance, right? And again, I don't know what the answer to that question is, but interesting to have the data so that I can tweak my parameters to optimize the data. And again, you want to run this in your real world application potentially, but the benchmarks in ProTop are really to give you a nice, fair, measured understanding of your particular environment. All right. So number 3. So if anybody's still running 10.2b08 or 11.x without the prefetch parameters, these are the default values, right? So prefetch factor, sorry guys. So prefetch factor here, 0. So don't fill the record. Prefetch numrec, 16 records. So the most records you're going to get is 16, and the message buffer size is 1024, and the numbers are not going to be pretty. I told you, right? So user experience localhost, look at that. We dropped user experience localhost by a factor of 2 or 3 almost in all cases. Now, interestingly, my physical sports and L sports didn't drop all that much, all right? But my network one, V sports, sorry, my virtual one dropped a lot. And then, sorry, that dash on VSP2 is simply because I don't know, something happened with my benchmarking and I don't have data. So we're going to rely on vSports for this particular benchmark, all right? And then looking at the client server, it gets even uglier here, right? So look at this. I mean, in client server mode, I went from 120 to 105 to 40,000 records per second on my virtual machine. And interestingly, on my physical machines here, so this is from virtual to physical, I went from 75 to 20,000 records. It's like a 4-time drop here in performance going from a virtual layer to a physical layer. And again, crazy interesting here, in my physical to physical layer from the laptop to the desktop, I went from 50,000 to 8,000, right? So that's a 6 times drop in performance. And so again, I stress to you guys, you need to test in your environment here. That's the most important thing. You have virtual to virtual, you have virtual to physical, you have all of these different things in your environment. You need to test so that you understand the numbers before you migrate to new hardware. before you make an infrastructure change, before you make a parameter change to a database that might affect some of these numbers. So keep these in mind. Use the user experience SHM, LH, and CS metrics in ProTop. They'll give you the graphs, they'll give you the numbers so that you can do these tests easily, quickly, painlessly in your own environment. All right, so graphically, this is what it looks like across the 3 benchmarks. So I mean, you can see here, it's pretty cool, you know. So you can see right away this darker line here, we drop here, bang, for user experience client server, and the other one above it is localhost. And the ones up here, those are the BOGO MIPS and the user experience shared memory lines, which don't change. Now, they are noisy, of course, because from one sample to another, there's quite a bit of variation. So if you were to zoom in on an hour, you would see like massive jags in the data. So always better to look at a longer time frame so that some of these jagged edges get smoothed out. All right, so this is vSports, the virtual machine, and then here's my laptop LSport. So you can see here again, my user experience client server dropped from around 50,000 down to around 8,000 reads per second. So that's pretty crazy. This little jump here, just in case you're curious, I didn't really talk about it, but when I noticed this jump here, when I went from minus MM8192 to minus MM32,000, I said, oh, let me just try it with minus MM16,000, and bang, I came all the way back up here. So you can see it's really telling. This is minus MM8192, minus MM32,000, and minus MM16,000. So you can see the difference here in performance, in client server performance based on the message buffer size. All right, and then the physical sports database, again, on my desktop computer, same thing. You can see the stair stepping going down as we changed from test 1 to test 2 to test 3 parameters. All right, so let me give you a couple of real world examples, and then I'll open the floor for questions from anybody. So here's a customer we have where they have their hardware with a managed service provider. So they're paying some external third-party company to give them the hardware, give them the virtual machines, and performance was horrible. It just was horrible, right? And so we put ProTop on there, and the first thing we saw with, oops, sorry guys. The first thing we saw with ProTop here is these are really slow CPUs. They had a BOGO MIPS value of 2. And to give you an idea, a modern CPU today has a value of 8, like a Xeon Gold is going to be an 8, 7 or 8, and even some of the more column value CPUs today will be in the 6 range. And so here's this customer and his managed service provider who's supposed to be giving them, you know, latest technology so that they don't have to buy their own hardware, is giving them this crappy CPU that's giving them, you know, throughput, sorry, a BOGO MIPS of 2 and a value of user experience shared memory of just around 100,000 or so. So we pushed the managed service provider to move them to modern CPUs, and he still put them on crappy CPUs. Here the BOGO MIPS is around 4, so he's not like, excuse me, it's not like he moved them to like super Xeon Gold CPUs, but right away we doubled the throughput, both on user experience LH and user experience shared memory, right? And that resolved the problem with the customer. And really it's having this data that allowed us to go back to the MSP and say, no, like you are not fulfilling your obligations as an MSP to put this customer on modern technology, right? That's the whole point of going to an MSP, so you don't have to buy new hardware every 4 years. The MSP is supposed to do that. Another classic one, if you're, you know, there was a time when people were doing physical to virtual migrations, P2Vs, or they were just incorrectly setting up their virtual machines on VMware, and they were putting these E1000, which is kind of the default Intel NIC in these virtual machines, and it was just horrible performance across the network. And so here you can see a machine that's got actually pretty, you know, again 3.6 is just okay, but he can do 225,000 reads per second in shared memory, only 17,000 reads per second in client server. So really classic thing. So we just swapped out the NIC from E1000 to VMXNet 3, and then the numbers went up from there. So again, very telltale signal here. And here's a bare metal server, just to show you something that's interesting about this particular customer. It's interesting that for a Google MIPS of 6, the user experience SHM is a little bit low, but I think it's because this is also a pretty busy machine. There's a lot of reads. Like this customer does around 2 million database reads per second during a typical day, so that could be affecting it. But what's more interesting is you can see that in this bare metal server, SHM, LH, and CS, they're all around the same size. So this is possible, right? If you have your network set up properly and configured properly, and your database is configured properly, it is possible to have SHM, LH, and CS on the same order of magnitude, right? So keep that in mind. You don't have to say that the best I'll ever be able to do is, client server communications will be 25% of shared memory communication reads per second. So it is possible. And the other thing to keep in mind is bare metal, I'm sorry, will always be faster than virtualization, right? Every time you virtualize or you hyperconverge or you put a SAN, anytime you do anything like that, you're adding a layer of complexity. So what are you doing? You're saving the company money by simplifying the management of the hardware, but it is costing you something. Nothing in life is free, and it's costing you performance, as your data and your processing has to jump through multiple layers before it actually does the work that it's supposed to do. So bare metal will always be fastest. It'll always be faster than virtualization, all else being equal, of course. So you will make trade-offs in your company based on cost, based on performance, based on availability, right? So, VMware gives you things like vMotion that you can't do with bare metal. So you make those trade-offs as a business and decide what's the best combination of performance, availability, ease of management for your business. All right. So how do you do this in your office? Easy. Go download Protop from protopeurope.com, install it on your server. The instructions are right there. There's a couple of tricky points for the client server, especially on Windows. So ping us, ping James Palmer or ping me or Tom to walk you through it. We tried to document it as well as we can, but again, you might have some questions. And then you can view the results in Protop real time. That's what Tom showed you earlier in the local character UI, or you can view it on the Protop web portal at protopeurope.com. All right, so final thoughts to close up. Did you notice how crazy variable everything was? And that's unusual. We usually do these benchmark talks and we show you, if you do it this way, you get this result, and if you do it that way, you get that result. But that is not the case. There's too many variable factors, I guess, in these network communications. You get too much variability. And like I just said earlier, virtualization, hyperconvergence, SAN, all of these solutions are there to save your company money, to make management easier. They are not there to make performance faster, right? There is no such thing as a high performance SAN. That's Tom's favorite expression, or rather my favorite Tom expression. There ain't no such thing as a high performance SAN, right? You're making accounting decisions to save money here, all right? And the last thing, which I've repeated and repeated and repeated, test, 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 test. Before you make a change, test. Know what the values are before, know what the values are after, and especially when it's an infrastructure change, which might be 2 or 3 kind of layers removed from your OpenEdge application, having this data available to you, and then a problem occurs, you can go to the historical data and say, you know what, a week ago I was like this, and yesterday I was like this, and guess what, today I'm like this. What did you guys do to the network? What did you do to the SAN? What did you do to the server? Oh, you vMotioned me, from a super fast server to some crappy old server, and now my performance is horrible. If I have the data, the historical data, I can go to the infrastructure team and I can tell them these things. All right. So open it up to questions here. Let me see if I can find the screen. Anybody have any questions?